Welcome. I'm Brent Staines, and this is my partner, Joachim Pasquale from Fiserv. And I'm not going to read the long title, but do want to point out the key part will be Spring Initializr. But we thought we'd start out today like all good afternoon tech talks with some nerd poetry. Many of you that's been around at all for Spring and Cloud Foundry deployment, there's this Haiku. It's very developer-centric, right? So you can all read it with me. We're close, right? Here is my source code. Run it in the cloud for me. I do not care how. But the reality is, for every Haiku, right, somebody has to care. So, but when I was searching for that online, I found another one, which I thought was pretty interesting. This is more from an operations perspective. So here are my servers. Go make them a Cloud Foundry. I do not care how. Of course, again, somebody has to care, namely the Cloud Foundry team. So I thought, well, how can we, join in? So I wrote a haiku for Spring Initializr. It's not copyrighted, so you can take it and change it or whatever. But it's pretty short. Initializr, complexity disappears. I do not care how. And in this case, though, somebody still must care. It's going to be Joachim. But we like everyone else on the cloud native journey, kind of set out with that idea, right? I want to live the haiku. How can I, CF push and life is grand? And we even talked and kind of set a guideline which say, hey, could we conceptually start out with an idea and be in development with the related artifacts in 15 minutes or less, right? And so that was kind of the guideline. Today's presentation is very much about how Spring Initializr encapsulates some of the complexity around the process. And it's going to be very technical though. And it's also, the point I'm going to come back to is you have to care. Somebody in your team is going to have to care, and you're going to have to kind of get dirty into the tool. So Joachim?
Yeah, thank you, Brent. We started converting a monolith application into microservices around 3 years ago. And this was the most exciting thing I have ever done in my business life, and later on also the stressiest one. But at the beginning is always the excitement, and the excitement was in the whole team. So we started to create Spring Boot microservice, and the developers were able to code the whole day long. There was no business requirements. There was nothing which avoiding you from using new technologies. This was really, really, really nice. And after a couple of months, we realized that we already have 30 plus microservices created, and that we need to get them somehow to production. So when we looked at that, this amount of microservices into a multi-cloud environment, we had a lot of test spaces, performance space, production space where we had to deploy. And you see 30 microservices, and you are solving partly at least the same problem in every microservice. When it comes to logging, for example, you're not supposed to log credit card data. So everybody has his own masking logic in the service, so that was not the best approach, of course. And then setting each microservice up in your software development lifecycle not only takes time, but also everybody does it a little bit different. Some steps are forgotten, and so it's kind of not unified. So that was the topics we wanted to address, and for that we are created, for example, util libraries which are taking care of logging and which took care of properties encryption, exception handling, and so on. We supported a little bit the micrometer metrics from Spring Actuator, enriched them with our own. So just give an example, the Oracle data source is not supported out of the box from metrics from Actuator. Configuration standards we established there. So now we wanted to get these libraries all in our microservices very fast. As Brent said, every service needs to be set up in a very short time frame. The next thing is we wanted to set up the microservice in our whole software development life cycle within these 10 minutes or 15 minutes. So you need to prepare a lot of stuff, configuration, each of the steps, right? How do you do this? And the next approach, a little bit later, we figured out when now something is changing, you're changing your software development life cycle, or you're just optimizing your pipeline, you're adding a new quality gate or whatever, how does this reflect to the existing services you already have? How can you minimize the work there? So automation is the key in the world of microservices. I think that's kind of a no-brainer even. This was something we wanted to address. So software development lifecycle, what does it mean? So here we have one example. It's probably that your software development lifecycle in your company looks completely different, might have more steps, less steps, different components. I'm quite pretty sure about this. But as we have used the Spring Initializr is just doing the very first step in your chain, right? So you still then need to create your Git repository, you need to create your pipelines. Your pipelines can include, of course, test execution, wiremark, JUnit, JMeter, whatever you're using there. It could have quality gates like Sonar, it could execute security scans and so on. From there on, you want to go and do the deployment on your environment. Some of us, or a lot of people, are using also pipelines for that from Concourse or Jenkins. Nowadays, a lot of people are looking already into Spinnaker. In our company, we are at the beginning of a proof of concept for Spinnaker, I have to say. But it's definitely worth a look, I would say, that you can see your whole environment in one view. You can see if the service is running, you can do rollback. Spinnaker provides a lot of templates and predefined steps to do blue-green deployment. I think they call it red-black. I'm not exactly sure what is the difference there. But it's really nice. And then you go to the runtime environment. So we are running on Pivotal platform, but the platform as such is not running alone. You have a metrics, you have someone who is recording your metrics. You normally have some kind of log dashboard, Splunk, Kibana, whatever. And you have a monitoring, alerting tool. And then some people say that the microservice also needs to be documented. So Confluence might be an option there. And Jira as collaboration tool is definitely also state of the art at the moment. So how do you get your service set up there? The configuration needs to be overall, and that should be generated out of the box, right? That's at least what you want to do. The prerequisite for this is that the components, whichever you're using, should require or should provide some kind of APIs. Could be a REST or a web service API. Nowadays, a lot of tools providing command line interfaces. And what's very helpful if you want to generate something is if this component provides some kind of human readable format, YAML or something like this. And it's very helpful if this tool also provides some kind of templating mechanism so that you don't have to generate the pipelines all over again. So the perfect fit. So these are 3 examples, just not the whole software development lifecycle components, but they're actually all of them are in the headline of the presentation today. So we have Pivotal platform, which does exactly that. It provides a command line interface called CF, so you can do a CF push. What you can provide there is a manifest file. The manifest file describes how you want to deploy your application on the Pivotal platform, how many instances you want to start, what kind of application you are actually deploying, if it's a Java application, Node.js or something like that. And the manifest file provides variable substitution. So you have some kind of variable placeholders in the manifest file, and then you can inject variables into the manifest file and push. So there, using this, you can push your application to Pivotal platform. Concourse does exactly the same. It provides a fly command line interface. It also has a pipeline defined as a YAML file, and it also provides variable substitution. Spinnaker as a continuous delivery platform works a little bit different, I would say. It provides also command line interface, the spin command line interface. The application or the template, the pipeline is defined in a JSON format. And I haven't found really a way to just provide variables, but what it provides is a template inheritance mechanism. And I will show in a few slides what does that mean, where's the difference in that. Generate versus inject. So when we started and we figured out we have all these components and we need to get them very fast into the life cycle, what we actually did, we created them. We had a generator, we used Spring Initializr, we extended that, and this was creating for us all the necessary files we needed. So for a manifest file, I actually created a manifest file for my development space in the primary data center. I created a manifest file for my development space in the disaster recovery data. I did the same for QA, CAD, production environment. There was a lot of files there. And then we decided that we have to have an installation in Europe. So I went back to the generator and we generated all the files again for the disaster and primary data center in Europe. So it ended up a lot of files. The same we did with the pipelines. And then we created actually some enhancement. We included Sonar in our pipelines. And you already have done this with 30 files. So you go back and edit every of your pipelines and push them again. The same for manifest files. You decide that the standard is 4 instances instead of 2. You go to every file again and do the stuff again. So we thought that is not really the approach you want to go further with. Every time you change something in your components, you have to go back in your generator and you have to regenerate all the stuff. Or if you are too lazy to regenerate, you have to go manually in all these files. And then, of course, in 10% of the cases, you forgot to do it. And then you have a production issue. So we only wanted to generate what's actually really service specific, which has nothing to do with the pipeline, just whatever you need and is different from service to service. So then we actually went to this approach here, handling permutations. I didn't find a better word for that, at least not in English. So we created a template. So a template, for example, in Concourse was the pipeline, but the pipeline was described very generically. There was nothing environment, region, or application specific in there. Every time you had something for the application name or the host name or whatever, we introduced variables. And then we created for each permutation, I would say, region, foundation, environment, we created variable files where only the variables are in which are region specific or so on. And then you just have to generate the application specific ones, which is mainly the name, right? So having this, you can now orchestrate your installation. So if you have now a Fly command line tool, you can go ahead and install your My application, provide the production, primary production Europe variables, push it to the template, and you can have a pipeline which is pushing your application to production in Europe. Yeah. So how does this look like for Pivotal, the platform? So we have the manifest file. This is just one small example, but you can see here nicely the route. The route, we have defined a convention. The route is a combination of the name of your application. It's actually the URL you can reach your microservice afterwards. Dash environment dot region dash host. And when you now have the variables defined for each of these components, then you can just combine them in one CF push command. You can see that on the downside where you can provide multiple variable files one after the other. Push a template YAML. If you have the manifest YAML default name, then you can even skip the last -f parameter, and your application will then be pushed like it's shown on the right side, that you have a myapp-prod.europe prime host abc.com. Right? Side note maybe here, the order of the variable files is important. If you have the same variable defined in multiple of these files, the last one will override whatever you have defined in the previous one. Concourse looks exactly the same. You also here have the placeholders in. You have your variable files, only that you are now using the Fly command line tool. In Fly, you can be logged in multiple Concourse installations at the same time. So you have to tell Fly with the -t parameter at the beginning to which Concourse you just want to talk at the moment. And then you give the pipeline a name. The -c is a pipeline file, which is a template, and then the -l is a variable file where you can also put multiple variable files, one after the other. Only difference is here that Concourse will not start the pipeline right away. It is in a paused state, so you have to run a second command, which is the onPause command, to really activate the pipeline. The nice thing here is that you can use exactly the same variable files. So you don't need to use different ones. You can use the same variable file for manifest, for pivotal, as well as you can use them for Concourse. You might have, for your example, I have the org one. You don't need that for the manifest file, so you might have different permutations. So now you can imagine if you can combine all these variable files with each other. And now you're going to Latin America and you're creating a new region. You create exactly one variable file, which is specific for Latin America. And you can immediately, with the existing variable files, create the pipelines and the manifest files out of the box without any changes for Latin America. Right? Spinnaker, as I said, is a little bit different. At least I have not yet found a better solution for that. But Spinnaker provides templates. So you're deploying your pipeline as you want to have it as a template in Spinnaker in the UI and give it a name. And if you then have a specific pipeline, you can reference to this template. So you see that here in blue in the middle of the page. So I'm referencing to the red-black deployment template here. But you cannot just provide the variable file. So they're expecting some kind of minimum structure, JSON format. It's not big, it's a small file. You can easily generate it with a Spring Initializr, but you cannot just generate the variable as such. Right? One of the features Spinnaker also brings in the template as such, you define default variables. So you see also a variable section. If you in your pipeline write some other values in, then these values will override whatever you have defined in your template. The other option you also have, as you inherit from the template, you can extend the template. So you can define more steps, other steps, which will then be added and will be specific for your pipeline. In Spinnaker, you first have to create the application. That's the first line, where you say, this is my new application, and I actually want to provide this with Cloud Foundry, or that's my cloud provider in that sense. And then afterwards, you can run the spin pipeline save command and push actually the right side result to Spinnaker. If you just run the second line first, it will not work because you are referencing to an application which does not exist. So extending the Spring Initializr. Out of the box, you probably know, you just go to start.spring.io, you're typing your values, you're getting a zip file. The zip file includes your Spring Boot application, ready-made in that sense, but you can also easily extend that. And I will show 3 demos today. The first one is you can add your own libraries. So as I said at the beginning, one of our issues was we had a lot of redundant code. We have created libraries which everybody should use. Now I want in the UI, I also want to be able to select it and generate it right away and not copy paste it afterwards in my POM file. The second one, I want to create this variable file, which I can then just use. I might even want to create the shell scripts which reply command line tools. So I could do that. That might not need to be, but you can do that as well. I want to extend the UI as a third use case. There is the existing UI, which looks nice, and I can also easily extend that. I just have to say that this is it's not intended to do so. So what I mean by that is you can do it, but you might get into some issues when the Spring Initializr team actually changing something. Initializr is now, since some time, divided into 2 projects. Before it was just 1 project. Now they have put the generator in the initializer project on the right side, and they have created the start.spring.io, which is actually the web application and the UI you're used to see when you go on the page. I wrote there, do not touch. That was not a don't dare to touch it. That was more, you don't need to touch it. It's just working and highly configurable. Right? But if you really want to extend the initializer, you can do this by forking the Start Spring IO project, which consists, I think, of 3 sub-projects, and we will look into 2 of them today. So one is the Start client, which is the React.js application, which is actually the UI, which you only have to touch if you want to extend it. And the Start side is a Spring Boot application, which provides a controller and REST API, or a controller, where the UI is sending the data to, and then the Start side is actually calling the generator to generate the project for you. So let's jump to the demo. So I said I will show 3 examples. The first one is when I want to add some libraries in the UI. The Spring Initializr has an application YAML file, as every Spring Boot application, only that in this case it's pretty full because it includes all the metadata information of the Spring Initializr. Every library is there, and there's also a lot of descriptions and rules. For example, if you're using Spring Boot 2.0, you cannot select My Library. You need to have at least Spring Boot 2.2 or stuff like that. There's a section where all the libraries are listed, and what I have done here, I just went in and created my own section. And in your own section, you can add libraries. And that's actually what you have to do. You define the group ID, the artifact ID, so you can put some description there. And then you can start it. And then you can already see, let me make this a little bit smaller. You see here the dependencies. You can here go to the dependency section, and then you see your dependencies listed above the others, because in the YAML file it's just in the same order, right? So you can then select it here, which then can also go and search for it. Perfect, right? So then you can generate your code. Okay. And then if you look into it and you go to this project, you can actually then see that your library has been added to the manifest file. So very easy example. So the second example is, how do I now can extend the Spring Initializr by really writing my own classes, my variable file. I go to the project. At the end of the presentation, I have a link to this Git project. There are actually feature branches where you can then load the single examples demonstrations. So stop this application. Stop that. I just make a refresh. So there's a templates folder in the Spring Initializr, and there are a couple of files already in there, and I just added one. I called it project-was.mustache. Mustache is a rendering template engine, or a template rendering engine, and it's already used by Spring Initializr, so there's no reason to not just leverage that. It's very easy to use. You just have the parts which you want to change. You just put it into double brackets or curly brackets. So that's my template. Then, if I want to extend the initializer, I have to write a so-called project contributor. Project contributor is an interface in the Spring Initializr. And you just have to implement this class, and you have to override the contribute method. So my contributor actually is using a project description object and the mustache template renderer, which I already mentioned. The project description object is a Pojo object which includes all the variables you have put in the UI, artifact ID, package name, and so on, right? And it's already in the application context as well. So the contribute method will give you the path to the root folder of your project. How the initializer works is that you have, it creates a temporary file on the file system, puts all your files in there, and then afterwards it zips and returns the return values. So I want to create the file project_var.yaml in my root folder. So I just create it here. Then I have a convention. I want to use the artifact ID as my name of my application. I just don't want to use uppercase camel. So I convert this artifact ID here to lowercase hyphen. That's a Google library which is supporting that feature. The renderer, the template renderer, requires me to provide a map, key value pairs. I just have one value, so I can easily use the collection singleton map. Then I render the file and I write the file out. So that's it. But the contributor will not be loaded automatically. You have to tell Spring that it should use that. Therefore, you're writing a Spring 1 configuration. So you know the configuration, you know the bean annotation, and we know that the project description object and the mustache template renderer is already in the application context, so I just can auto-wire it. So that's a standard configuration. The only important part is here that you don't have an add configuration annotation like in the normal Spring configuration class, but you have a project generation configuration annotation. So the reason is that the Spring Initializr creates these objects for every single request because there are different contributors for different combinations of what you want to generate. So if you want to have a Maven project, you need a Maven contributor, which is creating a POM file. If you have a Gradle project, you want to have a Gradle contributor. The same for Kotlin. You don't want to have a Java class when you select Kotlin. So you can put conditions. This is not shown here, but in the next example, I will show this how that works with the conditions. This will just be loaded all the time. So this project generation configuration, you have to register in the meta-inf Spring factories file. So as you see, the Spring Initializr already has a bunch of them here, and you just add yours at the end of the line, comma separated. Then it will pick it up and it will execute it. So we're starting the project. We are refreshing the site. And this is Vars demo. Give it a name. Generate the file. It's a little bit slow. So in the Vars demo root folder, now I have my project Vars file, and if I open that, then I can see that I have filled this mustache template with a name, and now it's not uppercase camel, but it's lower hyphen case. Right? Okay. So the third example is extending the application. And I want to go here back to the presentation for a second because it's quite a little bit difficult. So we have the start client and we have the start site project. And how it works, you can, in the start client, you can quite easily add one more input field. Application ID is the field we want to add. So the idea is I have an actuator endpoint, info endpoint, and I want to show application specific ID in that, so that's good for maintenance purposes. So this application ID with all the other values together will be sent to the controller as a request parameter, key value pair. And then there is a bean mapping which will map these request parameters to a web project request object, which is a simple Pojo. We have to override this class. We have to write our own one, which includes the application ID field. However, the generator is not working with the web project request object. The generator is working on a project description object. So we also have to provide our own project description object. It's even a little bit worse. This is an interface. I have to write my own interface. The project description object has a default implementation, and I have to override it. And I have to provide a project request to description converter. So a class which is transforming my web project request into my project description object. The controller I also have to override because I have to provide the model attribute. The default controller is returning a web project request. I want to return my own web project request. So these are the steps which we're doing, and might be useful for you then afterwards look at the code, because in these 10-15 minutes we still have, it's not 100% easy to follow all the steps. So let me stop that. Another thing you have to do, you have to recompile your client project afterwards. Because the client is a React.js application, and it just creates a UI new. So I'm just started that because it's running for some time. Yeah, it's running. One file of the two files is the index.js script, application ID. And what I have done, I have taken an existing input field, I have taken the artifact field, I have copy-pasted that, and put it directly under the artifact ID. And then I have renamed just the fields. So you see now it's application ID header line, and then it's using all the JavaScript, JSON object, it's using the application ID. That's not enough. There's a second file which is called API.js. And you find all the objects here which on the UI are preset with default values and all that stuff. So you find them 3 times in this file. So you're just searching for package name, and then you're adding the application ID exactly below that. So that's the first one. And then you have to extend this, and then you will find this another 3 times. One time here, it's using some query strings, and then there's some kind of get default values JSON. So that's constant values. If you have done that, then your application, then your field is added to the UI, and it will be sent to the server as well. That's all you have to do here. So on the start side, we now have the controller part. I said we want to create our own web request object. So I'm extending it, I'm adding my application ID, getter, setter, and I'm done. Very straightforward. And then I have my controller, which I also override the project generation controller, which is actually already a generic, so I can provide my web request object here. So I don't have to do a cast. I can just create my own Spring 1 web project request, and the rest is more or less copy-paste from the parent method and then return this object. Of course, I have to configure this controller in my Spring config, so that Spring is not using the default controller but my controller. I will just show this in a second. The other thing is, on the other side to the generator, we want to create our own project description object. So I have my own Spring 1 description object. As I said, it's an interface. So I just add my get method here. I have a mutable Spring 1 description object, which is actually extending the default project description object from Spring Initializr, and I'm adding my field getter and setter. And as I also implement my description object interface, I'm overriding the get application method. So, and then I have to provide the converter. The converter, as you see, is also generic, so I can also avoid any kind of casting here. Then I can create my own description object. I can use the default converter to convert all the other fields which are already in the UI. And then I can just add my application ID, which is the only field which I added, so the only field I have to convert from project request to project description. So that's it. So in my configuration, I have now to provide my controller. So my controller will override the default controller because the default controller has an add conditional on bean, right? So if I define a controller from the same type, my controller will override the other one. So I have here, by the way, I have to generate a project generation invoker, which needs my description converter as a constructor argument. And then I creating my controller, which needs the initializer metadata provider from the application context plus the project generation invoker. So it's not very easy, but it's not much lines of code. So now I want to use this file, right? I want to have this application ID in my application properties file so I can show it in my actuator endpoint. And now I'm doing exactly what I already did for the second example. Again, I have a templates folder. I have here my application ID, which I call company ID, which is not really nice, but that's how I did it. And it's again a mustache template. And what you can see here, I want to show also the project version and the project artifact ID in my info endpoint. And these annotations there, these add project version and project artifact ID, they are Maven specific. They will not work with Gradle. So my contributor should just work when actually the guy who has selected the application has selected, I want to have a Maven project. So I write again my contributor, which is doing exactly the same. So I'm not writing into the root folder this time, but I'm putting my application properties in source main resources. Another thing which was very important here is the application ID can be null, and the mustache template renderer does not like that. So you will get an exception. So I put a default value if this is null. Then again, I create my map. I'm rendering the content. I'm writing the file. You see there's a difference here. There's also the get order. I did not overwrite this in the other example, but the initializer is creating already an application properties file. It's empty, but it's creating one. So I want to be more important than this one. And another difference here is that I can now say I don't want to have a project description object. No, I want to have my Spring 1 project description object because I need the application ID field out of that. Configuration, I of course have also here to write my own project generation configuration annotation. And I'm just creating here my contributor. And now this line here is then important. This contributor is only loaded when the Maven build system was selected in the UI. Otherwise, it will just create the empty application properties file. So I think I converted the client already. Let me do one more refresh and then start the application. So you see here the artifact ID from the demo before, and I now refresh my page. You have here a new input field which is called application ID, right? I'm putting 1, 2, 3, 4, 5 and making app ID demo. Generate. This time it works much better. So now I have a source main resource folder. I have an application properties file where you can now see the application ID is inserted. I did a small mistake here. I wanted to actually show it, but to actually show it, I have to create a web project with the actuator endpoint and then generate. And then I want to change to downloads, app ID demo 2, no, not zip. I have not unzipped it. Unzip it. And I want to run it. Maven Spring Boot run. You might have figured out that I have done another change. I have actually defined the server port 8090, so I can run it on port 8090. And if I now go to 8090 actuator info, I now see the version number from Maven. I see the name, and I see the company app ID in my info endpoint. So that was all I wanted to show. Let me just switch back here to show also the link to the GitHub. And what I just want to summarize is I can use a Spring Initializr and create much more than the initializer prints out just for default. A big lessons learned for us has been that I don't want to generate the pipelines. I want to generate the variables which I need for the pipelines. And my pipeline as such is something which is in a Git repository. It's versioned, and if I change that, I just push my pipelines new. I don't have to generate something new. It's already everything there, right? And extending the UI, you really have to think if you really need that. As I said, it's not intended to be extended. And actually, when I added the application ID, the React.js JavaScript test cases from Spring Initializr, they failed. Because what they did, they do an assertion on the request string, which is sent to the server. And this request string does not include an application ID field. So you actually have to jump into the JavaScript test files and fix that. And depending on how good or how nice you think you can work with React.js, that's probably a 5-minute work, or that's something you don't want to touch, right? Okay. Do you think we have 5 minutes for questions? Is that right? Or not? Yeah. Okay. Any questions?
Can you use the initializer to extend it to create code for non-Java applications?
Yeah, so the question is if I can extend the initializer to create something which is non-Java. And the thing is, or the answer is yes, but what you have to use is the core Spring Initializr project, right? If you look at this Spring Initializr project, this has a lot of sub-projects. And one of them is Initializr, which is really the core, which is just providing you a framework, this project contributor interface, and it will call it, and it will honor the conditional annotation and the stuff, right? But it will not generate anything for you. Then there's an Initializr-Spring project, which actually creates the Java class, the POM file, the Gradle file, and so for you. And there's another Spring Boot, I think, which is then doing on top of that even more, right? So you can use a generator as a generic framework to generate something, call contributors, which you have to write on your own, and it might already zip the file. That's it. Yeah, that's a funny question because so the question was how I keep up with new versions. And I think the question is very important because they just changed completely how they did the Spring Initializr. The version 0.7 actually has a complete different UI and was only one project, and there was no project contributor. There was a talk from Stefan a little bit earlier today, and I think he got the same question, or he got the question if the API is finally stable. And he said something like yes. not 100%, but they're still working on 0.8, which was released on Monday. Until 1.0, there could be something which is not backward compatible. Yeah.
With Spinnaker, you've got your manifest file with your dash bars,
Mm-hmm.
PCF. Have you figured out how to be able to actually utilize that with a Spinnaker deployment?
Yeah, not really. Yeah. So what I figured out, or what was my understanding, is that I have to provide this minimal format, which is extending a template, but I cannot just provide the variables side. Yeah. But that would be a nice feature, actually.
They have a third party that does it then.
Okay.
That you can do the variable, but you have to pay for it.
Oh yeah. Okay. So he just said it's possible, but there's a third-party product where you have to pay for it. Yeah. Okay. Then thank you very much.